Okay, we're talking relations and functions today. So, some of this is going to be old news, but it's not a bad idea to refresh our memories. So, we'll just kind of walk through the notes here, and then we have some examples to do at the end. A relation, you have a set of ordered pairs showing a correspondence between two quantities. You can represent that several different ways. You can just list the sets of ordered pairs. You can give a table, like a t-table sometimes they're called, with an x and y value. You can give a graph. You can give an equation. And you know what? There's actually one more I'm going to add to this. Mapping diagram. Sometimes you see those. And that's kind of where you just you have basically one bubble that represents your x values, one bubble that represents your y values, and you draw an arrow between them. So like the point 1, 2 would be represented like that. If I wanted the point, 3, 2, it would look like that. So those are called mapping diagrams, so just another way to express same ideas, just your any type of relation. Now, if that relation, I'm going to jump ahead real quick, if that relation has each x value only going to one y value, then we call it a function. Okay, so if I look back up at my example that I just drew, every number in my x section, I guess, is only going to one y value, right? It doesn't matter that they're both going to the same one. It just matters that each of these can only go to one. So this would represent a function. If I did this, now it's not a function anymore, because 3 is now going to 2 different locations. So if any of my x's repeat, or if my x's go to more than one y value, that breaks the cycle and it is no longer a function. Okay? So that's kind of the difference between the two. Relations can be functions or not. All right? So, sort of to back up a little bit here, you have domain. That's another word for all of your x or input values. Those are your independent variables, right? And then, of course, you have the range, all your y values, dependent variable. Okay, all this is old news, right? Okay, so on the next page, we're going to talk a little bit more about how to tell if a relation is a function. Do you remember the vertical line test? Oh, good. I love this one. This is great if you happen to have a graph of your relation. So all you need to do is, we have 2 examples down here, you're just going to pass a vertical line along your graph. And if it only ever hits your function once at any given point, then it is a function. Because, think about it, each x value is only going to one y value. So when I ask you, what's the value of the function when x is 1, there's only one answer. What's the value of this function when x is 3? There's only one answer. It becomes not a function when you see something like this, right? As you pass that vertical line through, you can see it's hitting more than once in many locations. So if I ask you, hey, what's the value of this function when x is 1? Well, now there's 2 different answers. So that has broken the vertical line test. It fails. This guy is not a function. Functions, when I put something in, I can put anything in that I want, but I can only get one number back out. If I get 2 numbers, it is no longer a function. Easy enough? Old news? Okay, let's keep right on going. Now, you don't always have a graph in front of you. You could make one, but sometimes that's not very convenient, right? So, if you are just given an equation, there are ways for you to tell if it's a function or not. Okay? So, first thing you're going to do is solve for y in terms of x, so get y all by itself. And then you're going to kind of look and see, if you plug in an x, is it only going to give you out one y? Okay, so if you look at the first example, I'm going to solve for y, and now I have this new equation. Well, if I plug in a number for x, I'm only going to get one number out for y, right? No matter what I plug in, if I plug in 0, if I plug in 19, if I plug in 1,000,000, doesn't matter. It's only ever going to spit out one y value. And then if you compare that to the second example, do the same thing, get y by itself, right here. See that plus minus? That means when I plug in an x value, I'm going to get out two different values for y. So right here I know that this guy cannot be a function. So far so good? Yeah? All right. Then you may or may not remember function notation. I know you remember it because we've been doing it. So remember, you're just replacing the y with f of x. It doesn't mean f times x. You pronounce it f of x. And the f really is just the name of the function. That's it. You're just assigning it a name so that if you have more than one function, you have a way to refer to it. Instead of saying function 1, function 2, function 3, you just call it function f, g, h, whatever. That's all it is. So it's nothing fancy. And then this is just what variable are you using, right, in your function. All right, so we have this, and then you could rewrite it with function notation, and then it's very easy for me to ask you to evaluate that function f at different values. So if I said, okay, find me f of 3, that means to do what? That's it. You just plug in 3 for x, so it's really 2 times 3 plus 3. So f of 3 is just 6 plus 3 is 9. And you're done. You don't then, remember, that does not mean multiplication over there. So you don't then divide by 3 or anything weird. You're literally done. That's it. And the way that you could, I want you to think of this in your head is the value of the f function when x is 3 is 9. That's really what this notation means. So f function, that's just its name. If I were to plug in 3 for x, it would spit out a 9. Okay? Okay. So, on the back, there's some space for us to evaluate a function. So, we're going to make up a couple of different ones, and then we'll do some evaluating. Let's start off with an f of x. We'll make this one pretty easy. How about 3x minus 4? Then let's give ourselves a g of x. And let's make this one that. And then let's do one more. We'll do an h of x. That is, how about an absolute value? Absolute value of x minus 1, something like that. All right, so I have 3 different functions here. I'm just calling that one f, g, and h, just so we can distinguish them from each other. I'm going to ask you to evaluate a couple things. We'll start off easy-ish, and then we'll just add extra layers. So for my first example problem, let's try find f of negative 7, find g of 3, then find g of negative 1. And I'll stick a fourth one in here. Yep.
Is the third one supposed to be H? Two G's?
I want 2 g's, yeah. Then let's do h of negative 9. Okay, so give these 4 a shot. Okay, we got answers? Let's try the first one. F of -7. Give me your answer. -25, I'm hearing. That is correct. So that tells me which of these functions I'm using, f, so I'm going to go to this one, and I'm going to plug in a -7 for x. So you should have done the following. So that's -21 minus 4, -25, I agree. I feel like we're going to differ. Some of us are going to get one answer for this one, some of us are going to get another. Let me hear your answers. What'd you guys get? 15, you said? Told you. Okay, well, we can't have two different answers, right? So here's what we should be doing. We should be going to G, and we're going to plug in a 3 for x. Right? Watch. Okay, so we're going to plug it in. I'm replacing that x. So it's now this gets replaced with a 3. So I still have that negative in front. And then I have a 3, and then I have squared, and then I have a +6. Just like that. I should have left myself some more space in between the problems, but anyway. So yeah, let me just cover that up so we don't get not too much going on at once. Okay, so now I'm here. Now I need to evaluate this correctly. You got to be careful. This notation right here, like this, does not mean -3 squared. It doesn't mean -3 times -3. That's 3 squared and then take its opposite. Ah, yeah, so it's, yeah, we got, this is the most common one. Kids mess it up all the time. So -3 should be your final answer. Be very careful. So that's why I want to do a second G, where you're plugging in a negative number. So go ahead and reevaluate what you did for the third one and see if you still agree with your answer. If you want to fix it, fix it. So I'm still going to go to G, but now I'm going to plug in a -1 in place of that x. And decide for yourself if you evaluated it correctly. I'm going to write it down here. I need more room. G of -1. Oh, I tell you. You know what needs to happen? Ticonderoga needs to make a mechanical pencil. Because they're like top of the line. And like, oh, speaking of which, I have a new pencil sharpener over there. So you could go use that fancy one. I tried it out yesterday on my Staples pencils and they look great. But these are no Ticonderogas, right? That's what needs to happen. Because these, I don't know, they don't work for me very well. Anyway, G of -1. So, what you want to do is you want to take -1 and I want to replace that x with it. So that negative is still there, right? That's still there. So that's there. And then instead of writing x, I'm going to write -1. Now, I do want to take whatever x is and square it. So in order for me to, I really want to square the number -1. In order to do that, you have to write it like this. And then plus, oh my gosh, +6. So that should be how you wrote in that when you substituted in that -1. That's what it should look like. Now, let's evaluate it correctly. So, according to order of operations, there's nothing for me to do inside that parenthesis, but the next thing I need to do is the exponents. And I want to do -1 squared. So this is literally doing -1 times -1. That's +1, but then that means now take its opposite. So I should have gotten out right there -1 plus 6. So your final answer for the third one, 5. Be careful. So if you got 7, I need you to be extra careful. All right, and then the last one shouldn't be so bad because that one's pretty straightforward. I am going to pop in a -9. Oh, I guess actually this is, well, it doesn't matter in this one. Just remember that when you're dealing with absolute value, you want to figure out, you want to simplify what's inside the absolute value and then take the absolute value. you wouldn't take the absolute value of each one separately, right? And then do the operation. Do the inside first. So negative 9 minus 1 is negative 10, and the absolute value of negative 10, of course, is 10. Okay, let's add another layer to this. What if I asked you to do, we'll stick with those same three functions, but now let's try, what do you think g of a would be? I'll put a couple for you. Oh, let me leave more space. Should learn my lesson, right? 6. How about f of 3 minus h of 2? Oh. And one more. How about f of x plus 3? Try those three out. Same three functions up at the top. Yes, g of a, lowercase letter a. Actually, I think that made it worse. A, yes, lowercase a.
And those are for the same functions.
Yep, same three functions up top, f, g, and x. Okay, so this first one, it's not even a number in there. Guess what? It doesn't matter. You're still going to operate the same way. Whatever's inside that parenthesis, you're just going to take that and put it in place of x in that function. Whether it's a number or not, it doesn't matter. Whatever is in there, take it, stick it in there. So, in this case, it's g of a. So, I'm just going to go to my g function, and instead of having an x, I'm just going to put whatever is inside the parenthesis in its place. So, in this case, it's just an a. So, I should have, oh my gosh, it broke again. Maybe I'll try one of these. I don't know. I'm a big fan of mechanical, but it's not working out for me today. So, negative a squared plus 6. How's that? Is that all right? Okay. Now, number 6 is actually not that bad. It's just like two little mini problems in one. So I have to do f of 3. I'm going to get an answer for that. I'm also going to do h of 2 and get an answer for that. And then all I have to do is subtract those two answers to get one final, right? So f of 3, wouldn't that get me 5? Everybody agree with that, right? If I plug a 3 into the f function, would be 9 minus 4, so I get 5. Minus h of 2. Plug in a 2 into h. 2 minus 1 is 1. Absolute value of 1 is 1. Right? So 5 minus 1. The answer to this is just 4. Okay? Now, 7, this is another one that's a little weird because it's not just a number in there. I have x plus 3. It doesn't matter. Whatever it is in there. It could be anything. It could be a symbol. Who knows, right? Just take it and dump it into the f function in place of x. So, remember the f function was 3x minus 4. So I'm literally just going to write 3x minus 4 again, but instead of writing x, I'm going to write x plus 3. You do want to take into consideration what operation is happening, right? Here, this is 3 times x, and then I'm going to subtract 4. So I still want to do 3 times whatever is in those parentheses. So I am going to have to put parentheses around the x plus 3 and then minus the 4. So when I plug that in, it should look like this. 3 times, now instead of writing x, I write x plus 3, and then minus the 4. So double check that that's how you inserted this into the f function. You're not going to leave it like this though. If there is stuff that you can simplify, you should do that. So I can go ahead and distribute 3x plus 9 minus 4, so I really end up at 3x plus 5. Yeah? Are we ready to add one more layer to this craziness? Do you remember composition of functions? So, in other words, if I wrote this symbol, do you know what it means? Do you know what this would mean to do? You do know? I don't know, let's do 4, whatever. Do you know what fog means? Yes, it's f of g of 4. Another way to write this is like this. Those two notations are the same, okay? And they're interchangeable. You could use one or the other. I prefer this, but, I mean, you'll see it either way. And so basically what it means to do, you really want to work from, if it's in this notation, it's a little easier to explain. You want to work from the inside out. So I want to take the number 4, plug it into G, and then whatever that answer is, I'm going to take that and I'm going to then plug it into F. So it works the same way here. You just, whatever is closest to the number, you would take the number, put it into G, take that answer, plug it into F. So they both mean to do the same thing. You want to be familiar with both types of notation because you'll see them interchangeably all over the place. So let's try it. Let's take 4 and plug it into G. So be careful. So maybe I'll even, maybe I'll just do G of 4 down here. So G of 4 would be, careful with that negative sign, right? So that's negative 10 would be my final answer. Right? And now we take negative 10 and plug it into F. So that would now be three times negative 10 minus 4. So negative 34. That's my final answer. Oops, sorry. And that's called composition of functions, taking one and putting it into another. Okay, so maybe let me give you 2 more to try, and then I'll give you some practice. How about, let's do g of h of 2. And then let's also try h of g of 3x. Okay. Did we get somewhere? All right, let's try it. So 9 g of h of 2. Okay, so I'm going to do h of 2 first. Take the 2, plug it in the h, so that's just going to be the absolute value of 2 minus 1, so that just comes out to be positive 1. Agreed? Okay, now I take positive 1 and plug it into g. So when I do g of h of 2, I'm actually doing negative 1 squared plus 6, like that. And that notation, remember, means 1 squared, take the opposite. So negative 1 plus 6. G of h of 2 is what? 5. Okay? Did you get it? All right. 10's a little bit different, but we're going to operate the same way. Oh, and you know what I just realized? You should have parentheses around these two. So I should put that back on 8 also. Sorry. Okay. Hog. It's not really hog. It's h of g of 3x, right? So this notation, same idea as this. I'm just going to take 3x, put it into g, take that answer, and then plug it into h. So this one, my answer is going to still be in terms of x, but that's all right. So let's take 3x and put it into g. Oh. So what does that look like? Now, remember, you're taking whatever x is and you're going to square it. So in this case, x is 3x, and I'm going to square it, plus 6. Is that okay? Do you see how I wrote that in? And now I have to evaluate. So I need to do 3x squared. So that's really 9x squared, isn't it? And then I take its opposite. So I get negative 9x squared plus 6. So there's g of 3x. Now I need to take that entire answer and plug it into h. So when I do h of g of 3x, I should now take this whole thing, put it into h. So that's going to look like negative 9x squared plus 6 minus 1, all in those absolute value bars. And now let's just simplify as best I can. Okay, so that would get me plus 5. And that's really as best as I can do, right? So there's my answer. We're all right? Yeah? Okay, so I'm going to give you some to try. Let's stop this here.